Sir, you are muted, I guess.
Okay, hello everybody. Let's start today's lecture. I think I heard somebody has a question. Does somebody? Did I hear that somebody has a question?
Not geldin Aslan mı yapmış bu?
Yes, I have a question
Okay.
from last lecture.
Sure.
Why did we use const declare operator overloading for returning value?
You mean why there is a const in here?
Where is it? I can't see. No.
You mean, can you see my screen? You see my screen, right?
Yes, but there is a team screen.
Is it Teams? Am I sharing the wrong screen? Sorry.
Okay, I can see now.
Okay, yeah. Line 19, you are saying that why are we returning a const money object?
Yes.
Okay, that's a good question, and I will talk about it today in a few minutes.
Okay, thank you.
Are there any other questions? Okay, if there are no questions, maybe if I start from the beginning and let me kind of do a few like a review. When we do the operator overloading, remember the operating overloading is something very simple. It is a form of function overloading, no different than function overloading. The only thing is that when, as I said many times last time, when the compiler sees an expression like this, a plus b, doesn't matter what the types of a and b are, compiler thinks that, okay, this is a function call, like a function call, and the name of the function is operator plus, and the parameters are a and b. If it's a global function, if it is not a global function, maybe it's a member function of the class that is the type of this object a dot operator plus b. Okay, so this is the basic idea of operator overloading. If you overload this function or this function, then you are overloading this plus operator. Okay, remember the name is overload. What is the meaning of overload? You give a new meaning, an additional new meaning to an existing function. Okay, to an existing function. The function has to be existing. You cannot create a new operator that doesn't belong to C syntax or C++. It has to be an already existing operator. You are giving it a new additional meaning or overloading it. So the idea is exactly the same as function overloading, but we are doing it with the operators. As we said before, in C there are operators that behave like this, and there are operators that behave like this. So these are binary operators, these are unary operators, right? And there are ternary operators like this one. You remember this ternary operator? It uses this one. This is not overloaded in C or C++. We don't overload it. So we overload only binary operators or unary operators, and there is one exception. There is one operator that can take as many parameters as you like. Okay, we will see an example today. And other than that operator, we are going to deal with these kind of operators. Question: we know that there could be functions like this, right? A function that doesn't take any parameters. Okay, we know that this could be a possible function. Okay, a function that doesn't take any parameters. Could there be an operator that doesn't take any parameters? Could there be an operator that doesn't take any parameters? Do you remember anything like that? Maybe you might think that maybe there is, I don't remember it. The answer is no. I mean, there is no operator that doesn't take a parameter. All the operators has to take one parameter, two parameters, sometimes three parameters, sometimes 4, 5, 6, 7. Okay, so there will be no operators that doesn't take any parameters. Okay, so that was the basic idea, and the whole chapter, all operator overloading, is based on this idea. But there will be some cases where we have to be very careful. Okay, like let's look at this one, for example. There will be many exceptions. Come on. Why can't I make this any larger now? Maybe do this that way. Like that. For some reason, I cannot make this any larger. You go there, plus. No. Okay. Let me use the best way to fix this problem. Okay. So, I am going to give you an example of an exception where we need to make exceptions, because this idea sometimes doesn't work very well. Okay. Let's try this one. Go away. Okay, let's try this one. This one. It will be either operator, okay, operator minus b, a global function, or b dot operator minus. That's it, right? No problem with this. Okay, no problem with this. Let me get rid of these. Okay, this is good. But how about this one? How about this one? Plus b. It will be either operator plus b, or b operator plus b. Okay, the same thing, b plus. So what am I going to do? Operator plus b, and b dot operator plus b. Do you see the problem here? Do you see the problem in this picture? They are exactly the same. Their signatures, I mean, if I like to overload the pre-increment operator and post-increment operator, their signatures are exactly turning out to be the same. If I overload this one, am I overloading the... I think there was a disconnect. Let me try to... Okay, I am connected both ways. There should be no problem there. Okay. I am both connected with the cable and the wireless. So if I am overloading this operator, am I overloading a pre-increment or the post-increment? So there will be some questions, there will be some details, and we will talk about this in this lecture. Okay, so but the basic idea is this. Okay, basic idea is this. Okay, so let's move on. Again, we talked about the operator. Any operator that you like to, almost any operator that you like to overload can be overloaded in C++. That way, C++ says that if you have designed and implemented a new class, those class objects could be accepted, they will be accepted as fundamental C++ class objects, such as integers and doubles. Whatever you can do with an integer, you could do the same thing with the class objects of yours. For example, your money class. That's what the main argument is. Okay, So we already talked about this, and there is this global function implementation of an operator overload, and I already showed you how the things are done, and this was the implementation of an operator plus. Okay, this is a global function overload. As we say, as I have stressed out many times, we don't like global functions. Okay, because global functions does not obey the rule of encapsulation. Encapsulation is putting all the data together and defining all the functions that can work on that data, and those functions are specific to that data only. Okay, they cannot be used anywhere else. So the global functions, they can be called anywhere from anywhere, so we don't like it. Okay, so we like our functions to be encapsulated in the same capsule. Global functions do not obey these rules, but for the sake of teaching purposes, we make this global, and there will be some other cases where we need to make some stuff global. Okay, so it takes two const reference objects. Okay, well, we take them as reference objects because we don't like the copy, because these are large objects. Okay, because these are large objects. I think somebody's microphone is on. Could everybody turn off their microphones? Turn off your microphones. Okay, thank you. So I take references, but also I know that I am not going to modify these objects, so I make them constants. And there was a question a few minutes ago from Bahadur. He said that why are we returning a const money object? And we will talk about it. In fact, I am going to ask you, why is this a const? Okay, and what would happen if it is not a const? And this is kind of, we tried this before actually, and I said that instead of doing that, maybe we can, I mean, it is the same as this one. Can I find it? Can I find it? Yeah. Remember this one? I said that this notation and this notation is almost the same. Both of them are making a new object. Okay. This one here, it makes a new anonymous object. Okay. This is an anonymous object, and it returns a copy of that object. In my case, the code that I have modified, I make a temporary object and I return a copy of that temporary object. Okay, so if in the case of anonymous object, that anonymous object doesn't have a name, but it's a temporary, I know. In my case, I name it temp, a temporary, and I return a copy of it. Note that I keep saying copy of it. I am not returning the object itself. I am returning a copy of the object. Okay, you cannot return this object because this object is a temporary object and it will die after this function ends. Okay, you are returning a copy of that object. Okay, let's go back to the slide again. Okay, so this is a plus operator for the global function. Equality operator, it works exactly the same. And you may ask, okay, Bahadur, your question. How come we are returning a constant money but not constant Boolean, right? Why don't I return a constant Boolean, right? So Bahadur's question is, I am extending it, and we will talk about this too. Again, it takes two constant references and it returns a Boolean, and this implementation is as simple as this. Almost all equality operators will be implemented like this. So you just compare the dollars part and the cents parts, and if they are both equal, then your two money objects are equal, otherwise they are not. Okay, good. And okay, this is Bahadur's question. He said that No, this is not Bahadra's question. Okay, this is Bahadar questions. Okay, we are returning a constant money object. Why? Why are we returning a constant object? Let's say I am not returning a constant object. I am returning a non-const object. Okay, I am returning a non-const object. In that case, let's say I have two money objects, M1 $100, M2 $5.25, and let's say I have M3 $0, and I am trying to do this. I am trying to do this. Okay, question. Can I do this? M1 plus M2. Okay. It is returning me a constant. It is returning me a money object, and whatever the result is, I like to print it out. Is this possible? Question. Just say yes or no. There is a. Let me go to the definition. Okay. Line 18. Output. Yeah. Okay. It just says that you can call this output on a money object. The answer is, of course, yes. I could print a money object on my screen because plus operator returns me a money object. Then no problem. How about this one? M1 plus M2 dot. Let's go there. And okay. Let's call this function input. Line number 17. Let's call this function input. Is this possible? Okay. I am not returning a const object. Okay. I am returning a money object. The answer is still yes. The answer is still yes. Why? Because I am returning a non-const object. With the non-const objects, okay, I can call with the non-const objects, I can call input or output, because with the non-consts, okay, with the non-consts, input is possible. But what does input do? Input modifies this object, right? Input modifies this object. So I will get some dollars and cents from the keyboard, and I will assign to this temporary object, anonymous temporary object. Okay, this is a nice code. This is not so nice. It is legal but not nice. Legal but not nice. Why? Because it is legal because I can call it. The compiler will compile it. But it is not nice. Why? Because the numbers that I get from the keyboard will go to some object, okay, and that object will be killed as soon as this line, execution of this line ends, right? So I don't like this. I don't like this. I don't want something like this to happen to my customer, my code customer. So I say that let's eliminate this. Let's eliminate this one. Okay, let's eliminate this one and make it constant. Since it's a constant object, only constant functions could be called on that object. So what could I do? I could call get amount, I could call get colors, get cents, or output. I cannot call this function 17, line 17 input, because input is a non-const function. Non-const functions cannot be called on const objects, you remember? Const keyword. Okay. So that's the idea of returning a const object from an operator or from any function, as a matter of fact. From any function, as a matter of fact. Okay, so if you don't like these kind of things to happen, okay, if you don't like these kind of things to happen, okay, you don't want to call this one, so make it a constant. Make it a constant. Okay, go back and do the same thing with the booleans. Okay, why don't I return a const boolean for this function, line 32? Okay, for the booleans I don't have these kind of problems, because with the booleans you are just returning a boolean value. Okay, with the booleans I don't have this kind of modifier functions available. Okay, what can you do with a boolean? What can you do with a boolean? Okay, it says it's just a value. I am not returning an object. Okay, so that's why if the return value is a fundamental type, if the return value is a fundamental type such as booleans, doubles, integers, characters, whatever, okay, we don't return constant doubles. We don't return constant integers. If you like, you can, there's no problem, but the custom is for the objects. Okay, what was our rule when we pass parameters to functions? We pass them as references if they are objects. Okay, we pass them as call by value if they are fundamental types. The same rule applies for the return types too. The same rule applies for the return types too. If you are returning a fundamental type, it's just a regular return. Otherwise, you are returning a constant object if that's what you want. Okay, is this clear? Okay, so that's Bahadur, that's the way we like to think actually. I mean, always ask questions. Why are we doing this? Why is this that way but not that way? Okay, and never think your question as like this question is a stupid question. If I ask this question to the professor, people are going to laugh at me and etc. No, don't think it that way. Any question that you have in your mind, just shoot. Okay, and it's good for me too, because it lets me explain even more. If I am missing something, if I forgot to mention something, even if I didn't forget it, okay, sometimes the words that I'm using may lead you to understand it in a different way. So let me help you, okay, understand the concepts better. If you don't ask questions, then there is no way I can know what you are thinking in your head. Okay, so any questions so far? You might think that what is so big, why are we discussing why there is a complete section for this? What's going on?
B1 and B1 plus.
Somebody said something, but I didn't hear it because my connection again is acting up.
I'm repeating.
So Bahadur, yeah, tell me, so what are you? Ask the question again.
I understand after this operation.
I could only understood you said after this operation. Why don't you type it? Just type it. Sorry for saying this, but I did not understand it. Okay, while Bahadur is typing his question, again, why are we so careful about this operator overloading? Why there is a complete section about it? Because at the beginning, remember, we said that it is as simple as overloading functions, right? Yeah. But I mean, it lets me talk about objects. It lets me talk about this constants reference and etc. It's a good point to kind of make a review of what we have achieved so far. Okay. And overloading operators is something interesting, and many languages do not support this, and it lets us understand the concept even better. That's why we are spending so much time on it. Okay, good. So we already looked at the money program using the global function overloads, and later we are gonna look at the same program using the member overloads. Okay, as we said before, unary operators is possible. One of them is negation. The others are pre-increment, post-increment, decrement operators. There are many unary operators. Remember our precedence table of operators? There were many unary operators, and their precedence is higher than the precedence of the binary operators, right? So the unary minus is done first, and the assignment operator. When you say A plus minus B, I know that unary minus will be done first. Okay, unary minus will be done first. So Bahadur has a question. He says that B3 gets the value of B1 plus B2. After that, can we modify B3? Okay, so the Bahadur says that, yeah, okay, let's do this. He says that there are these money objects B1, B2, and B3. And he says that B1 gets the value of B2 plus B3. Can I do B1 dot input later? And I'm asking the same question to you guys. Can we do this? Because this operator returned a constant object, right? Can I do this? B1 dot input? Fatih says no. People are saying no. Everybody is saying no. Karaman says yes. The answer is, so other people, they don't have. So Yunus Emre, you are saying that it is copying it. So like integer is 3. It is exactly what Yunus says. Okay, 3 is constant, right? I am copying a constant to an integer a. Later I can modify the value of a, right? I may assign another integer to a, right? So, of course this is possible. Of course this is possible. Why? Because b is a non-const object, right? Did I say b is a constant? No. b is a non-const. I can do whatever I want with b. I modified the value of b1, okay? I modified the value of b1 by copying the result of this addition. I modified it. Later I am modifying it again. I am not modifying the returned object, okay? I just assigned it to another one. Okay? It is exactly what Yunus Emre says. It is exactly what Yunus Emre says. This is no different than assigning a constant to an integer and modifying it later. You cannot say that I cannot modify B1, because whatever you can do with B1 depends on the type of B1. B1 is not a const, non-const. How about this one? Can I do this? Const money. How about this one? Read this code and tell me what happens. Is this okay now? Okay, whoever says no, why? Just tell me why. Use your microphones. Use your microphones. Why is this not okay?
It is a constant.
Well, that's the beginning of the answer, but you need to complete that sentence. So it's a constant object, so what?
You cannot modify its content.
So where am I modifying it?
In the input function.
No, before that there is assignment operator, right?
Oh, okay. Sorry. Okay, I didn't see
Assignment
that one.
operator is a problem here, and after that this input is a problem. Okay, after that the input is a problem. So there, I think Burak is asking a question. Doesn't plus operator return a const variable? We don't call it const variable. Okay, variable varies. We say that the const object. Okay, yes, it returns a const object, but it's an object. I use it to make an assignment to this B1. Okay, let me try to make this a little bit more. Okay, what does this mean? This means this. It means compiler is doing something like this. Operator assignment B1, comma, operator plus B2, comma, B3. This is what the compiler is doing, right? So whatever operator plus is returning, I am sending it to this assignment operator as a second parameter. So that assignment operator is using that object to make a copy of it to this object B1. Okay, I am modifying B1. Okay. Good, so B1 is a constant, that's why I mean, if B1 is a constant, then this is not going to work, because this operator assignment will take a non-const object in the first parameter. Second parameter is a const. We did not overload any assignment operators yet, but we will see it later. Okay, any other questions? Any other questions? Okay, let's move on then. Overloading the minus operator, unary minus operator. See that the global one takes the single parameter unary. Okay, the implementation is very, very easy. And we already talked about this and how we use this minus operator here. Okay, remember there are two operators going on. One of them is minus, the other one is the assignment operator. As we said before, there is a default operator assignment, and it is defined for us. And if you don't like it, we are gonna overload it ourselves. But for this case, it works okay with us. Okay, look at this class definition. This is the class definition that I like most. Class A. Okay, this is the class definition that I like most. It doesn't include anything. It doesn't have any private part, public part, any constructors, any operators, and etc. Still, this is not a completely empty. Why? Because this is possible, right? This is possible. That means that this one has a default constructor, right? So a default constructor is defined automatically. Okay, this is also possible. B, C, and a pointer of it, right? So I could say this: B gets the value of C. So the assignment is possible. Assignment is possible. What else? I could do this: Cout size of A. This is possible too. So size of operator works on it, no problem. And I could do this: PT gets the value of B, right? So the address of operator works. Okay. Size of operator works, assignment operator works, and the no parameter constructor, default constructor works on it. Now there are many operators and functions already defined on a class, even if you don't define anything. Okay, an assignment operator is one of them. You need to know what assignment operator, the default assignment operator does, and you need to know what default constructor does on your new classes, because if you don't know what they do exactly, you don't know your class. And if the customer uses this assignment operator and the constructor in a way that is not intended, then you will be in trouble. Okay, good. Okay, so we said that at the beginning, as we said, that the function, global functions are not the only ways of doing the operator overloading. In fact, in object-oriented programming languages, we don't like global functions. Okay, we don't like global functions in object-oriented world. Okay, so it is possible to overload them as member functions. Here they are. Okay, so the same four functions: binary plus minus, an equality operator, and unary minus operator as member functions. Remember, see, I don't have two parameters now. I have just a single parameter, because the first parameter is my object itself. Okay, so that doesn't mean that one of the objects is missing. No, there are two objects for the binary operator. Okay, one of them is the parameter, the other one is my object. Okay, for the second it is the same. For this one, don't read it as there are no objects to work on. Of course, there is. This one and this one is no different. Okay, it's like calling input, calling output, calling input or calling output. Okay, good. And implementations are already, I have given you last time. It's very similar to what we did before. And minus operator is like that, and the equality operator takes, it just compares my dollars with the dollars of the other one. Okay. I think there was a question last time. Somebody asked me this question. This was a nice question, actually. When I look at this one, second operand and cents, how come I can access somebody else's private data members? Somebody asked me this, and I said that publicness or privateness is for the classes, not for the objects. Okay, if I am a function of a class, I am a function of a class. I am not a function of an object. Okay, the difference is very important. I am a function of this class. That means that this function can access the private data members of all the objects of that class. Okay, since operator minus is a function of class money, any money objects that I have created or I have received, I can make modifications of their private data, no problem. Okay, no problem. But the better way of doing this is not accessing directly their private data members, but doing it using their public interfaces. Even though I could say dollars and cents here, right? I am not doing it. I am doing it in a way that public interface is my way of accessing them. Okay. Somebody might say that, I mean, instead of like here, you would say cents, here I am using get cents. I mean, calling the function, interface function, is inefficient. Why are we doing this? This is inefficient. You are making a function call, and that function call is returning the sends. This is inefficient. Why don't we access the sends directly? And to answer that one is, no, this is not inefficient. Why? Because usually I implement my getters in the class, and when I implement my getters in the class, am I back on? I don't know what's going on. Okay, I think I'm back on. Because I can see my captions coming back. So I was talking about the efficiency and inefficiency. No, this is not inefficient. The book says the other ways, but I don't agree with the book because these are usually inlined. Okay, when you inline a function like that, it is as efficient as accessing the data members directly. Okay, so in object-oriented programming world, we don't think efficiency as our number one concern. Okay, we try to do the right thing first. Do the right thing first, then be concerned about efficiency later. Okay, doing this is right. Always try to use the public interface, even if you are a function of the class. Okay, even if you are a function of the class, do the right thing, use the public interface. So you are obeying the rule of information hiding. Okay, even if you can have access to the private data directly, don't do that. Use the object-oriented way of using the getters and setters. If it creates some problems later in terms of efficiency, we will try to figure out some solutions for that later. Okay, usually it will not be a problem. Our computers are fast enough to handle this kind of inefficiency. Okay, good. Okay, good. So this is how we implement our operators as like member functions, not global functions, but member functions. Okay, overloading as member functions. And remember, one parameter, not two, and you have seen the difference. You have seen the difference. Okay, I talked about this, and we talked about the program, and a class has access to all its objects. Functions are functions of the class, not the functions of the objects. Okay, don't get confused about it. Okay, so let's go back to the discussion of which operator overloading should I be preferring. Okay, which one should I prefer? Of course, in the object-oriented programming, member operators. We like the member functions better. Okay, it's the spirit of operating object-oriented programming, and they are more flexible. Okay, why? Because if you are the member operator, if you are the class member, even though I told you not to access these dollars and cents directly, there might be some member functions private you may have access to, and in some cases, if these two don't have any getters and setters, well, it will be more flexible if you do it with the member functions. But with the member functions, there is one significant disadvantage, and it is not efficiency. Member functions has a very big significant disadvantage, and we will see it in a few minutes. Okay, Yeshim has a question. Does a nested class have access to the outer class's objects? Yeshim, no. Nested class is a class by itself, and nested class doesn't know where it lives actually. Okay? It thinks that it's a standalone class. It thinks it's a standalone class, and it doesn't have access to the outer classes objects, outer classes data members. But the opposite is not true. Okay? Because I am the outer class, I have access to the that's my class because, right? Okay. So let's move on. Remember this function call operator that I talked about? Okay. This is a special operator. Why is it special? Because this function call operator could take as many parameters as we like. Okay, could take as many parameters as we like. Sometimes it doesn't make much sense for the to call them function call operator. For example, let's say I have a money object M1. Okay, what is the meaning of M1 2710? I mean, let's say I have overloaded this operator with these parameters 2710. Doesn't mean much. Even this one, what is M1 2? Doesn't mean much. Okay. So I mean, but it is okay to overload it. Let's try to overload it with this as a member function. Let's say, I don't know, this is going to be very stupid function overload, but for the sake of just saying it, operator parentheses, and interesting syntax here. Let's say it is going to take an integer, another integer, and a double. I could do that, okay? And it's not going to modify my object. Okay, this is one way of overloading it. I could overload it in many different ways. For example, I could do just another stupid overloading. Doesn't take any parameters. It looks weird, but I could do it this way. Okay, let me try to find you an example where this overloading of this operator makes sense. I think the C++ class, C++ string, I think it implements this operator. No, I think it did not implement it. I thought it implemented it. Does vector implement it? Let me see if vector implements it. Maybe it implements it. Where is vector? Okay, let me go back and type it in here. Assignment operator, index operator. No, unfortunately, I don't have it. Okay. C++ STL operator. So it is a very rare actually function to overload. I'm having difficulty finding an example. No, I cannot find it. Okay, sometimes they implement they overload this. Okay, let's say I have a string s, its initial value is a b c d e, and sometimes I can say string s1 gets the value of s 2 and 3. That means that starting from the let me make this 1 and 3. Okay, this is position 0, this is position 1. So I get these 3 characters, make it another string, okay, and assign it to this s1. So it is kind of a substring overload. Okay, so that doesn't make much sense most of the time, but it is for you to overload it, and this operator can take as many parameters as you like, of course, other than parameter 0. It has to take as all the operators that do, it has to take at least one parameter, which is the object itself. Okay, let's take some break. 10 minutes. We will come back and we will continue our discussion of the operator overloads. Let's be here around 11:34.
Sir, before you go, can I ask something?
Okay, when we come back, you may ask your question.
Okay.
Okay, let's continue. So somebody had a question?
Yes, sir, I had one.
Okay.
Can you go back to the notepad?
Go back to where?
To the code, to the notepad plus plus.
Okay.
I can see it still. Okay, came back. So at the 23rd line, there's a double without any variable name. That kind of confused me.
Well, I mean, I don't have to specify. I don't have to specify any of them, because these are the function declarations. It is up to me to give a name at the function declarations to the parameters. This is from C. I don't have to say any of them.
So
I can
how do you
erase.
access it in the future?
What is that?
Inside of that function, how do you access that variable if you don't give it a name?
Well, I did not implement it, right?
You know you did not.
Okay, so if you implement it, of course you have to give it a name, but if you don't implement it, these are all okay.
It's for, okay, I understand now. Okay, thank you, sir.
Okay. So let's go back and let's continue our discussion. These are the function call operator. Function call. As I said, this is not a very common function to overload. Usually with the function overloading, there are some functions there are some operators that you overload many times. Some of them are not really overloaded. Some of them should not be overloaded. Okay, for example, these the AND operator, OR operator, or comma operator. Remember the comma operator? Okay, these are special operators because they specify the order of evaluation. This one says that I would evaluate on the left, then if it is true, then on the right. This one says on the left it is false, then on the right, etc. Okay, but usually the idea is we don't overload these kind of operators because the short circuit evaluation goes away when you do the operator overloading, and it makes it confusing. Okay, and we prefer not to overload them. Generally, we don't overload these operators. Okay, so these are the details of operator overloading. Some of the operators are not possible to overload. Some of them we don't prefer to overload. Okay, and some of them has some issues when we do the overloading. Okay. Okay, let's go back and let's talk about this piece of code. Look at this code. Our money class. There is this base amount and full amount, and this plus operator. Look at this plus operator. It looks like it's a plus operator. Somebody has overloaded. It looks like there is a, let me go back to the, okay. It looks like somebody has overloaded plus operator with an integer, right? Like that. Line 20, line 20 reads like this, okay? This code works even if I don't have this line 20. I don't have line 20. I'm just erasing it, okay? With this implementation, with line 19, this code works. That's because I have automatic type conversion. What do I mean by this? Okay, when the compiler says that, what is this? This is base amount dot operator plus parentheses 25. What is 25? It's an integer. Are there any operator plus overloads that take a integer? No. Can I make a money object using an integer then? The answer is yes. Why? Because I have a constructor that takes an integer value and it returns a money. So the compiler automatically, okay, passes to the money constructor, money 25. It makes a money object, and that money object is used to call this plus operator, because now I have a money object. This is called automatic type conversion. Okay, this is called automatic type conversion, and it works. You don't have to do anything. All you need to do is, okay, in your class definition, an appropriate constructor that converts from this integer to a money. Okay, it's a conversion constructor. Okay, this one is a, okay, we didn't intend it that way, but it is used as conversion. It's a conversion constructor. Okay, and this one could be another conversion constructor. Okay, this one is another conversion constructor. So that means that this one works. Okay, this one works too. Base amount plus 10.50. This one works too, because why? Because this is a double, right? This is a double, and from this double, are there any operator overloads that takes a money object and a double object? No. Can I make this double into a money object so that I can call the money plus money? Yes. So I can call that other constructor. So what is the constructor? Constructor that takes a money. 10.50. Okay, so this is done automatically. This will be called automatically. And if you like to really see how this works, okay, go in there and do this experiment. Where are my constructors? Yeah, here inside these constructors, just type cout statement, cout, okay, int constructor, and then inside this is a double constructor, right? This is double constructor. Okay, and the body is not empty anymore. And do the same thing with the int constructor. Where is my integer constructor? Where is my, okay, this is my instructor, int constructor here. Okay, and this is the integer constructor. So do this experiment and execute these lines, this one and that one, and you will see that those constructors are called in those lines. You will see that this is happening automatically. Okay, this is happening automatically, and we like this one. Why? With this feature, I don't have to overload this plus operator for integers, for doubles, etc. Right? All I have to do is provide a constructor for the integer, provide a constructor for the doubles, and my plus operator and minus operator starts working with the starts working with the integers, integer plus money plus integers, right? So this is very good advantage. Okay, this is very good advantage. But the problem is this: it works with this one, it works this one, but it doesn't work with this notation 25 plus base amount. Okay, it doesn't work with this one. Why? Because I cannot say 25 plus dot operator plus, right, and base amount. Why? Because 25 is not my object. Okay, 25 is an integer, and I did not overload this member function for this integer class, so this will not work. This will not work. Okay, with this approach, this will not work. And I really like this one to work because I really like this one. But I want this to work. So what am I gonna do? Is, instead of overloading my overloads, instead of doing my operator overloads using the member functions, I am going to do them with the global functions, unfortunately. If I do the global functions, both this one and this one is going to work. Just a minute, I need to take this phone call. Sorry. Okay, sorry for that. So that's the idea. Remember what we said before? We said that. Okay. Member operators, we prefer them a lot, but non-member operators, although they are global functions, they have a significant advantage. The advantage is this: if you do the global function operator overloading, both of them did this work. Money 1 plus 10 will work. 10 plus money 1 will work. So this one already works for our member operators, member function operators. This one will work for both of them. Okay, this one will work for both of them. So in order to able to have this kind of flexible operator overloading, unfortunately in C++, we prefer our operator overloads. Using non-member functions, global functions. That's what we are gonna do. Okay, and that's why we introduce you how to overload the operators using the global functions. Okay, you have a question? Sure. Yeah, ask the question.
I mean, if we write the plus operator overload with an integer argument, should we use call by value or call by reference for that integer value?
I think the rule is the same. I mean, the operator overloads are just function calls, right? If the
Yes.
operator overloads are just function calls, then that means that when you pass an integer to a function, how do we do it? We do it with a reference or with a call by value. We said that we don't, integers and doubles are so small. We are not concerned about their efficiency in terms of copying when we do the call by value. Okay, they are as efficient as sending a reference or pointer. Okay, so we send the value itself, not the reference of it. The rule is when you're sending a value to a function, okay, when you are sending a value to a function, send a reference to the function. If it's an object, if it's a fundamental type, send the value of it. Okay, so that's the rule.
Thank you.
Okay, any other questions? Good. Okay, if there are no questions, let's move on then. So that means that this is the way we prefer doing things. Global functions, but global functions are global. That means that they have to always use the public interface, but sometimes we need more flexibility. What do I mean by this? When I do this plus operator, of course I could use the get cents or get dollars interface. I know this, but let's say if I don't have this get dollars function, okay, in my class I don't have the get dollars or get cents. Sometimes, I mean, I don't have to do it, right? I don't have to have the getters for all the data members. Maybe I have only get amount. Okay, I don't have these getters. So what am I gonna do with these global functions? They cannot access the private data members. Or maybe this plus operator needs to call these dollars part, cents part, and round, which are private functions. So what are we gonna do in that case? Since they are global, they cannot. So the answer is this. Answer is this. Friend functions. Okay. There is this concept of friend functions. Some people don't like these at all. They are our non-member functions. They are global functions, but they are allowed to access the private data members and private functions of our class. Okay, the friends can directly access private class data and class functions. Okay, so if they can have access to class data and class functions, they are more flexible. No overhead of calling the getters and setters and etc. Okay, and since they are global functions, they will be very flexible for making these kind of calls. Okay, these kind of calls, 25 plus base amount or base amount plus 10 plus 50. Okay, so this is the way we are gonna do our operator overloads. That's the way we are gonna do our operator overloads, and how we do that, it is very simple. This is what we do. We say that, okay, line 19, we say that there is a global operator plus function. There is a global operator function plus operator function. It is my friend. Okay, see this line 19? This is not a member function because it takes two parameters. When I say friend, it's a friend function. It's a global function. It's not my member function. But as a class, I am telling that that function can have access to my private data members and private functions. And the same with minus, same with equality, same with unary minus. 4 of them. Okay, and the class says that these are friend, and the implementations are the same as before. These functions are global functions, but they don't say that I am the friend of such and such. Okay, friendship are given, not taken. You cannot say that I am a friend of this class. You don't see the class name here, right? You don't say money and column binary scope resolution operator. Okay, and the same with binary minus, binary equality, and unary minus operators. Okay, this is, remember, the friend is a C++ keyword like void or const or private. Okay, it's a C++ keyword, and you specify a function as your friend, and now in that function, as you see, I have access to the private data members of the class, like that. Okay, so if we go back, I mean, these are not very correct things to do in a typical object-oriented programming language, because, as I said before, we don't like the global functions, and now we say that to make the things work for this kind of stuff, okay, to make the things work for this kind of stuff, okay, I have to do this globally, because I cannot do this with a member function, right? Why? Because 25 is not my class. 25 is integer, and I don't have access to integer class. So what am I going to do? I am going to do with a global function, but with the global functions, I have the problem of not accessing the private data if I need it. For that, I am making global function my friend, okay? And friendship, as the name implies, is not a nice thing in the object-oriented programming world, okay? Friendship sounds nice, but it is not nice for the object-oriented programming, because you don't make anybody your friends. You say that all the data, okay, all the data and all the functions that belong to your class should be encapsulated together. You don't need anybody else. You don't need any friends, okay? But now you are saying that, okay, I have some other functions that doesn't belong to this class, but they are going to access my data. That's not a good thing. That's not a good thing, friendship, okay? That's not a good thing. So in operator overload, let me talk about this again. Friend function purity. Okay, the spirit of object-oriented programming dictates that all operators and functions be member functions, and many believe friends violate the basic object-oriented programming principles. Okay, for the operators, it is very advantageous. It has advantages. Why? Because we are doing this for this kind of stuff. Money plus 5 plus money, right? 5.7t plus money. If I do the global plus operator, they all will work. Okay. I'm sorry, I need to get this call. Sorry. Okay, class. Something important came up. I need to stop at this point. We will continue tomorrow morning, okay? I think Mohammed has a question. When we use operation overloading using constructor, is constructor need to return object? Well, no. No. You are not changing your constructors at all. Your constructors are exactly the same. The constructor doesn't know that it is being used as a conversion constructor, okay? It is all done automatically. If the constructor takes a single parameter, and if it is needed, like in your case, b1 plus 25, the compiler knows that I can make a new money object out of that 25, and that constructor will be called automatically, and that constructed object will be used for that plus operator. Okay? So I need to stop here. Tomorrow morning we will continue, okay?